Okay, so anybody watching on the YouTube event, it should be live now.
Okay. Okay, got 17 people waiting.
Wow.
You're live. I see it. Yep.
Okay, so now Jim, if you speak up, Roxanne, I'll have you tell me if you can hear Jim through the broadcast.
I've been hearing it as a long delay, but yes, I can hear it.
Yeah, there's going to be a delay. That's fine. Okay, might be a little disorienting, but I'll take it. Now, what I'm going to do, I'm also going to keep an eye on the broadcast and see if there's any questions that show up in chat.
Okay, I got 3 people talking, so whomever needs to talk on YouTube. Okay.
Let's exercise mute control here. If you're not talking, then please go on mute.
Whoever needs to talk on YouTube. Let's exercise mute control here. If you're not talking, then please go on mute.
Okay, and for the folks that have been waiting here, waiting for the broadcast, showed up a little bit early. Welcome. We're just kind of getting our sea legs underneath us for our first live broadcast here, our first online only event here. So again, welcome. I appreciate you stopping by. And looking up here, the sky is mostly clear. And we'll just have to, just hope it stays like this for the next half hour or so, 45 minutes that we'll be broadcasting here, and we'll get you a look at this comet.
Adam, did you see the satellite come through the picture?
Yes, it is drifting through slowly. I caught that earlier when I started the exposures here. So. Yes, it is drifting through slowly. I caught that earlier when I started the exposures. So a brief reminder to our early birds here. If you want to ask a question or give a comment via the chat in the live stream here, you will need to be a subscriber of our channel. So if you have a comment or question, go ahead and hit that subscribe button and ask away. I will relay your question then to the experts that are also with us on the broadcast.
Hey, Adam, I'm in the stellarium. I'm trying to identify these little clusters that are off to the left side of the image. Those two brighter stars are two of what are called the kids in the constellation Auriga. Auriga is a chariot, and the brightest star is a goat pulling the chariot. There's three other stars nearby that are called the goat's kids. Well, those two stars to the right of the comet are two of the kids.
I haven't done that. I'm gonna hop in there and try to change some video stuff. Yeah, Jim, keep that information in mind as we get through the broadcast. We'll kind of cycle through that as people come and go in the feed here. Okay, I see a couple more folks have hopped on here. I just want to say welcome. We're just kind of getting everything dialed in here, and we'll officially be starting in just a couple minutes. But feel free to enjoy the view that we've got up for now.
Okay, so you have hopped on here. I want to say welcome. We're just kind of getting everything dialed in here.
Aaron from Enola, welcome. Thanks for subscribing, and welcome to our show. Okay, and I see it is now 9:30, so we are officially live here. We turned this on a few minutes ago just to kind of get the video dialed in here, test a couple things out, and I think we've got everything about where we want it. So again, welcome. We've got the Comet already in the view for you here, and so far the weather appears to be holding up, so we should be able to give you a pretty good view tonight. We'll probably keep this open for about a half hour, and we'll get some rolling commentary from some of the other the Astronomical Society of Harrisburg club members that are going to be commenting on audio here, and I'll be relaying questions to them. And so if you have any questions, make sure you go ahead and hit that subscribe button. That will enable you to enter a comment in our chat. So if you have any questions, go ahead and reach out and we will answer those. So from our some of the folks that are on our audio here, what can you tell us about this comet?
Well, I guess I can start here. I'm Jim Davis, by the way. I'm the club secretary. The comet is a long period comet. That means it has come in from the Oort cloud, which is a cloud of debris that was kind of tossed out of the solar system when the planets all formed out of the solar disk, out of the nebula that the sun and the planets formed from. And they're way out, far, far, far beyond Pluto, kind of just drifting in a very, very slow orbit. But every so often, two of the things get near each other and they perturb it. And all they need to do is change their speed by a slight amount and they fall back towards the sun. And they're made of ices and rock and dust from the formation of the solar system. And when they get near the sun, they start to heat up. And what we're seeing coming off this thing, that the core, the comet is lost in that little cloud there. The bright part is called the coma, and the rest is the tail. And as it warms up near the sun, the ices turn to gas and they expand, and that's what creates the comet tail. So it's this long period comet's been around before by the path of its orbit, but the last time it was near the sun was 40,000 years ago. A little bit more information on what you're seeing there besides the comet, which is the fuzzy thing kind of center left. The two stars to the right, the brighter little circles, are two stars in the constellation Auriga. Auriga is supposed to be the charioteer, a guy in a chariot, but instead of being pulled by a horse, it's pulled by a goat, which the star that's the goat is not in the field of view. It's a star called Capella. It's one of the brighter stars in the sky. But there's three stars nearby that are the little baby goats, the kids, they're called. Those two stars are two of the three kids. So it's kind of neat that the comet is near them right now.
Yeah, good evening. This is Doug Grove, one of the members. I'm a past president of the club. And I'm sure some of you are looking at the naming of the comet. Well, there is a convention to how comets are named. In this case, it's named for, well, this one in particular. It was discovered in 2022, which is why 2022 is part of the name. And then E3 indicates when during the year it was discovered. What's done is the year is broken down into 2-week increments, and essentially 2-week increments, or even half of the month, depending on how you want to look at it. So This one is E, which means it was discovered in the first 2 weeks of March in 2022. And it was the third comet discovered in that time frame. Now, the ZTF on the end of this particular name stands for the Zwicky Transient Facility, which is an observatory looking for such things as comets and other what they call transient phenomena, something that is not a permanent type of thing like a galaxy or stars or star clusters, anything like that. So what you'll see is, and it depends on it depends, like I said, it depends on the type of comet it is. This one is a long period comet, so we see it this way. A shorter period comet, the one everyone is probably aware of, is Halley's Comet. Those have a shorter period, and those comets actually have a P in their name, meaning it's a periodic comet. It comes back every so often, depending on, obviously, each comet has its own orbital period. Comet Halley is 1P because it was the first comet that was determined to be a periodic comet, one that returns. I'm not quite right offhand. I don't know how many actually, without checking, how many actual periodic comets there are. But if you see something with a P in its name, you know it is a short period comet, one that comes back usually within a human's lifetime, for the most part. Some of them are, relatively short period, 4 and 5 years. You have Halley, which is 76 years, and the periodics are considered a periodic up to, I think it's around 200 years. Just because there has to be a cutoff somewhere, so that's where they decided to cut it off at 200 years. So, and on top of that, quite often, the discoverer will actually be listed as part of the name. So if I would ever discover a comet, it could be referred to as Comet Grove. Like I said, Halley's Comet, that was a 17th century English astronomer who calculated that a comet that he found in the record was coming back every 76 years based on what was found in the histories, whether it was written by a historian or something out of the church, where they had records that they could see that, oh, here's a comet that came in this year, and then 75 or 76 years later they saw another comet, and then he calculated this is a comet, and he calculated when this comet was going to return, and unfortunately he passed away before it returned, and I forget how many years it was before it returned that he passed away, but that's why it is called Halley's Comet, because he was the one that calculated, oh, this comet's going to be returning. And quite often they're named for the discoverer of the comet as well.
Well, one of the things we're often asked is, what are comets made of? And early when the solar system was forming, there was all sorts of chemicals and pieces of rock and pieces of dust that were forming, and they collected together to make the planets. They also collected together to make comets. Now, comets form far enough away from the sun that things you normally think of as a gas or liquid were frozen. So a lot of what's in the comet is water ice. Same thing you get in ice cubes. But it's also things like methane and ammonia and nitrogen and things we normally think of as a gas. So as the comet comes closer to the sun, after its long dive from millions of miles away, it starts to warm up, and those things that have been frozen as ice since the beginning of the solar system start to evaporate. And the comet center is like a big rock, but there's gas amongst it, pieces of rock, pieces of ice. People call it a dirty snowball. Well, it starts to evaporate, and it forms a cloud around it, which is called the coma. And that little bright center you see to the comet is the coma. But then it starts to trail away, and it makes the tail. So some of the tail is the evaporated gases, water, ammonia, things like that. But when the comet froze, it also collected a bunch of dust, because elements floating around in the solar nebula were clumping together and forming bits of dust, and they clumped together more, they became rocks. Well, the dust gets pushed out with the gas, and a lot of the reflectiveness of the tail is due to dust streaming away. And it's not being left behind as the comet moves, because everything in the comet's orbiting at the same speed. But sunlight pushes on it, or solar wind, little particles thrown out by the sun, and they push it away from the sun, and that creates the tail. Well, this one here is famous as being a green comet, and there's a number of comets that are green. But one of the things that got frozen into the ice when it formed was carbon. And we don't run across individual little carbon atoms floating around on Earth. They tend to either clump together and make graphite or coal or diamonds, or they combine with something and make methane or carbon dioxide. But there was nothing for them to react with, so they carbon just reacted with carbon. And they'll have little C2 molecules in there. Well, a carbon-carbon bond is not a real strong one. So when it gets released out of the comet and then it's floating around again, light from the sun will break it apart. And when chemical reactions happen, particularly in space where it can get away, the exact amount of energy released by that breaking gets released as a photon of a certain wavelength. And the carbon-carbon breaking happens to be green. So as all those little double carbon molecules break, they give off green light. And that's what's causing this comet to be particularly green.
And speaking of the tail, as Jim was saying, the tail is actually always pointing away from the sun, because the sun is emitting particles all the time, which is called solar wind, and the solar wind is strong enough.
Technical details about how we're getting this picture here and what you're seeing. What we have is one of our purpose-built astronomy cameras that is connected to a fairly small telescope. It is only 80 millimeter aperture, and I believe. Sorry, go ahead.
No, go ahead, Adam. Okay. As I was saying, the tail is pointing away from the sun because of the solar wind, which is the particles.
Okay, thank you. So yeah, we're using a fairly small telescope here, and I'm using that because that gives us a fairly wide field of view. That lets us see as much of the comet as we can. Unfortunately, due to a number of conditions, we can only see a little bit of the comet. You can see, of course, the green glow and some of the dust that's spraying off of it. But this comet actually has a fairly long ion tail that is kind of hidden in the details here. So we have this camera that it's taking 30-second long exposures, and that allows us to capture a lot of light in a single shot here. So you're not going to be able to see this kind of detail with the naked eye. Unfortunately, what we're also competing with here is some local light pollution and also a full moon, which is a huge factor in how much light from the object that we're trying to capture here. So if it weren't for the full moon, we might be able to see a little bit more detail out of that comet, including the tail. So but when we're dealing with a lot of light pollution like that, especially what comes off of the moon, we're kind of limited in what we can see. So part of my job here is kind of finding the best combination of settings with the camera here, working with the local light pollution so we can see as much as we can see with the given conditions.
Hey, Adam, can you explain the magnification?
Well, I was hoping that one of you guys might have a better answer for that. It's kind of hard for me to do that math when we're talking about, magnification. So magnification is more of a factor when you're using an eyepiece here. There is a way to convert that into when we're using a camera and how that kind of translates into what's called image scale. Let me do a little bit of homework on that, and I will get back to you on that.
To add in for Adam Weiss, can't just tell you right off the top of my head. Magnification, when you're talking magnification, you're talking about angles, the angle from one side to the other. When you're taking an image, there's no angles involved. So you kind of have to fudge some numbers to get something that's relative to that way of measuring. And as the broadcast goes on, Notice the comet's getting farther and farther away from that star just to the right. So it is moving across the field here. It's fairly close to Earth, and so its motion across the sky is pretty fast right now.
Okay, in this field of view here, I found a tool that'll do the quick calculation here. The field of view that we're looking at is 2.86 degrees by 1.95 degrees.
This field of view here, found
And if you're thinking of the sky in terms of 360 degrees, it's about 3 degrees out of that 360 degrees. Now, it is interesting. I imaged this comet a couple nights ago from the imaging scope I have set up at my house. And it's interesting to see, it's almost a time lapse with each frame that you take. You can see the comet that is moving ever so slightly, just a few pixels on every shot. But like Jim mentioned, if you've been watching since the beginning here, you'll have noticed that the comet has actually moved quite a bit from where it was at the start of the broadcast here. So this thing is definitely trucking. What are we doing here? Why? It is on delay, so if you talk, it'll be.
Hi, Dave Mitski here. I'm a longtime member of ASH, served in many different capacities, and I've just been observing the comet with an 8-inch Newtonian reflector on a Dobsonian mount, commonly known as a Dob, as well as with our 12.5-inch Cave Astrola Newtonian. And it is just a dim glow next to one of the stars in the Kids asterism. So you may be able to see it if you have binoculars and you can keep out of the moonlight, but it won't be much of a spectacular object by any means.
Okay, we have a question here. It says, is the relative speed constant? The answer to that is no. When it was closer to the sun, it was moving faster. As it moves away from the sun, it slows down. Now, it's not slowing down a tremendous amount at the moment, but what's making it really be quick right now is it's nearby Earth at the moment. the comet came in south of the plane of the planets, rounded the sun, and is going back out north of the plane. So that's why a few days ago it went right by the North Star. And currently it's very close to Earth. And the closer it is, the more of the larger the movement we see. As it moves away from Earth, even though it's slowing down as it goes away from the sun, it'll move less just because the distance it moved is farther away from us and looks smaller. One of the other things you see in the images, there's a lot of stars in the background. That's because currently it's passing through the Milky Way, the band of stars in the sky. Now this is the winter part, where we're looking away from the center of the galaxy and there's fewer stars. It's hard to see the winter Milky Way in the sky unless you're someplace really dark. When you zoom in on it, you realize it's lots and lots and lots of little stars. So and there's a little cluster of stars off to the left of the comet there, towards the edge of the field.
Yeah, we have a question in our comments here. Is the relative speed fairly constant, or is there a significant change due to proximity to the sun? All right, let me go check on that. We'll get you an answer to that.
as Adam was saying earlier, the moonlight reflects off anything in the atmosphere, and it kind of brightens the whole background. So any dust or water or whatever's in the atmosphere. So it's hard to pick the comet tail out of that glare. The moonlight reflects off anything in the atmosphere, and it kind of brightens the whole background. So any dust or water or whatever's in the atmosphere. So it's hard to pick the comet tail out of that glare.
All right, so any of our other club members that are helping us with some of the information here, if you have anything else that you feel like sharing about the Comet, love to hear what you got to say. Otherwise, I think we'll shut down the broadcast for now, and we will keep our eyes open for some better weather, some good weather ahead, maybe a little bit less moon, and we'll have another broadcast like this showing what's hiding out there in the night sky.
Well, thanks, Adam, for running this scope and broadcasting this. It's been very interesting, and I hope the people watching have learned a bit about this comet.
All right, everybody. Well, thank you very much for coming out tonight and sharing the view here. And we hope to be able to offer another show like this in the near future and give you something interesting to take a look at and learn something new. So again,
thank you very much.
and we'll post when the next event is. So check us out on Facebook, Astronomical, or this is actually the Naylor Observatory on Facebook. And again, if you haven't subscribed to this channel, do so, and you'll be alerted to upcoming events. So thank you all very much, and have a good night.
Yeah, I was imaging it with the 10 the other night. I just took a couple single shots. I mean, even 30 seconds was a blur.